Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. I talk about laboratory compaction test. This compaction test is very important for any kind of the project, how much the soil has been compacted, because there is a certain code and the specification which one has to maintain, and it should achieve the targeted compaction. Without proper compaction, many structure may also collapse. So, you need proper verification for the compaction test and also proper to check up whether the soil has been compacted properly or not. So, for this it is very important to determine the compaction characteristics of the soil sample by using the standard Proctor compaction test. So, this from the prehistoric time, the builders have recognized the importance of the compacting soil to produce a strong settlement free and water resistance mass. The densification of the void occurs due to reorientation of the particle. The energy consumed in this process is supplied by the compactive effort of the compaction devices. So, you need that how you can reduce the void ratio and increase the density of the soil to achieve the proper compaction. So, there is a definite relationship between the maximum density to which the soil is compacted and the moisture content of the soil during the compaction. First of all, that R. Proctor 1930 and devised a test by which it is possible to determine in the laboratory the moisture content that will give the maximum density with the selected expenditure of the energy. Soil particle absorb a film of water when added to dry soil. On further addition of the water, and this film get thicker and permit soil particle to slide over each other easily, and this is called the lubrication. Because of the lubrication, the addition of small amount of water to dry soil aids the compaction process up to a certain point. Additional water replaces air from the soil voids, but after a relatively high degree of the saturation, the water occupies the space which could be filled by the soil particle. Therefore, there is an optimum amount of mixing water for a given soil. That means that optimum moisture content, and compaction process which will give the maximum weight of soil per unit volume. That means what should be the maximum dye density. So, you will be knowing that what will be the maximum moisture content, what will be the maximum dye density, and then you can establish a correlation between the maximum dye density and the corresponding the moisture content. So, the condition of full saturation when air in the void is completely expelled is called the zero air void or saturation condition, and the relationship between the water content and the dye density of this condition is called the zero air void line. For example, that let us say that gamma of D is equal to gamma of D is equal to 1 minus n of A into G into gamma W, this divided by 1 plus W into G. For zero air void, this Na is 0. So, this is the percentage air void. So, gamma D can be written as G into gamma W divided by 1 plus W into G. So, here gamma D is the dye density, gamma D is dye density, and gamma W is unit weight of water, and G is the specific gravity, and W is the moisture content. Moisture content. But this also you can write this gamma D is equal to G into gamma W divided by 1 plus W G by S, where S is the degree of saturation. That is, if it is 100% degree of saturation, then S value will be the 1. That means equation will be gamma D G gamma W divided by 1 plus W D. So, S value may vary. For example, if it is 100% S value, then equation will be gamma D G gamma W 1 plus W D. That means this is 100% degree of saturation. So, here S is equal to degree of saturation. So, from this equation we can draw the zero air void line. So, for the compaction test we require that some apparatus and accessory. This is the standard Proctor mold with a base plate and collar. You require the standard Proctor hammer. You need metal tray, weighting balance of 1 gram accuracy and 0.01 gram accuracy. Then it require trowels, measuring cylinder which is about 500 cc, moisture cans, and extract jack, and scraper, that is straight edge. You require oil and grease or oven to dry the soil sample. So, these are some of the equipment which is required for the compaction test. Here you can see, this is the standard Proctor mold with a base plate. this lower one is the base plate, and then color. And this is the standard Puchter hammer. This one is the standard Puchter hammer. That is blue color. This is standard Puchter hammer, in which the soil is to be compacted into this mold. And this is the straight edge. This is the moisture can in which soil is to be placed for drying. This is the oil, and this is the dry oven for the determination of the moisture content, and this is the measuring the cylinder, and this is the metal tray in which soil is placed. So, these are the some equipment you require, and this is the weighting balance is here. So, testing procedure for standard Puchter test. Note the dimension of the mold, color, and the base plate. Take the empty weight of the mold, that is without the color and the base plate. Then you apply a thin layer of grease on the inner side of the mold and affix it to the base plate by means of a wing nuts provided. Place color on the mold. Take about 3000 grams of air dry soil passing through the sieve size 4.75 millimeter in a tray. Note the hygroscopic moisture content of the soil. You know that how to determine the hygroscopic moisture content of the soil. Now, add approximately 4% of water to the soil in a tray, mix thoroughly with the towel and cover it with the moist cloth. Next, determine the Puchter density. Place the soil in the mold in 3 layers, 50 millimeter thick each, in a loose state. Give 25 blows to each layer using the Puchter hammer, which I showed you. What is that Puchter hammer? Scrape the top surface of the layer before placing the next layer of loose soil. Then remove the collar, trim the soil with a straight edge, disconnected the mold from the base plate, and then you take weight. Take 2 samples, one from the top and other from the bottom of the mold for the determination of the moisture content. Extrude the compacted sample from the mold, break it in the original size, add another 3 to 4% of water, and repeat step 7 to 10. Continue the operation until a decrease in the weight of the soil is observed for at least 2 successive readings. Draw a plot of moisture content versus the dye density and determine the maximum dye density and optimum moisture content. On the same graph, can plot the constant degree of saturation line, 100%, 90%, 80% degree of saturation, and estimate the degree of saturation corresponding to the maximum dye density. So, we can from the compaction test result, we can determine the relationship between the moisture content and dye density, and we can determine what is the optimum moisture content and corresponding the dye density, and as well as we can determine for any degree of saturation, either 100%, 80, 70, 60, etc. From this curve we can determine. Thank you.